So I've got on my iPad here the construction manual for the Heathkit C3, and so we're just looking at hopefully the same picture. So it says on the left side we should have two yellow leads, on the right side two black leads, and then it looks like a red and a red yellow and a green and green yellow coming off the back. So let's go over and have a look. So this side should be two black leads. They look black to me. On this side we should have two yellow leads. Try and get some light so you can see. I'm not sure if the colouring on the camera shows them up, but they certainly do look yellowish to me. We should have a red and a red yellow. Let's just try and spin it round. There. These should be red and red yellow, and then these two should be green and green yellow. Well, I'm not going to lie, it's quite difficult to tell. But the wires are in, some wires are in place. Okay, so that's that. So going back to our build diagram, our build instructions, you can see a layout. What I'm actually looking for is, where are you? There's the wiring of the transformer. But it wouldn't surprise me if it's going to throw me a curveball. Ah, here we go. Circuit diagram. I'm actually going to try and put this as a picture-in-picture. Here's the power transformer. So this is saying primary side. Can I turn that upwards? Yeah, look at that. Oh, iPad changed the orientation. Hold on. There we go, back working again. So the primary side should be a black and a black that connects to our inputs and our switch. So we can go back over. Oh, not too far. So what I'm going to do is I'm first going to measure the DC resistance between those 2 points, and I'll do it as a picture-in-picture to show you. So the two black wires. I wonder if this isn't the export transformer. I think it's just a US voltage one. So I'll have to make a decision on what I want to do with it. Anyway, so let's follow those two black wires underneath. And they come out of here. I believe it's them. Yep, and they're twisted and they end up there. So I'm going to measure, let's get you in focus, between those 2 points and write down the reading. Okay, so the two connection points are this point here that's got one of the black wires going to it. It's got a 0.05 microfarad cap to ground and another wire shooting off from it. So where is that on the circuit diagram? There's the switch. Here's the black wire. There's the 0.5 cap to ground, and this other wire must go off to the on-off switch. So that's this point here is our first connection point, and the second connection point is and this here is the power cable, and it just simply connects to the same point there. So we'll have one on there and one here. Right, on with the meter. It's not overly accurate at low resistance settings, so it's just a case of letting it bounce around. Basically, I'm just checking that it's not an open black to black is, what's that about? Sorry for the beep, it's the continuity buzzer. 5 ohms. So black to black, it's 5 ohms. So I've just confirmed that it's not an open connection, or an open winding, should I say, which is good. We like that. Happy with that. Okay. Our next one is we'll look at the high voltage side. So that's a 500 volt winding. So we've got a red and yellow to pin 3. There's also linked to pin 5, the grid. Remember I said it's a triode wired as a diode. And our other point will be to the negative side of, oh look, there's those 2 8 microfarad caps and it's showing them in series. One of them has got a 47k cap in parallel connected to pin 8. So let's go down to our socket. So right, where's our key? Our key is here. 1, 2, so here's pin 8, positive to ground. Yeah. And then also from there, you've then got the positive cap going to pin 1. Now pin 1 is obviously used on here. No pin 1 actually used, so it's obviously an internal connection that connects to, follow this wire over the 2 bumps to one of the switches. Wow, so that's how they've done it. Okay, so I've managed to get the circuit diagram the right way up on the iPad. So we can test it anywhere really between that point there and pin 3. So what's that, pin 8, wasn't it? Pin 8. So it's the two red wires that come off. Here they are. So we've got pin, is that pin 1? Pin 1. Oh, sorry, no, I lie, yeah. Pin 1 is the connection point for one side, and pin 3 is the connection for the other. So let's measure between those 2 points. So over here, I just quickly wrote out primary, black to black, 5. Secondary, red, oh god, to red, yellow, equals. So one connection there. When I'm measuring voltages later, I'll do the same connection points. So it's coming in at 1,722 ohms, 1.7k. So that's not open either. That's a good thing. Excellent. Right, next one. So the next one is our 55 volt winding, green to green yellow. Our connection point, well, I'll just follow the wires and see where they connect actually. Let's find them. They might be on top actually. Okay, yeah, so this green and the green yellow, one connects over to the wafer switch, and the other, so this one down here, and the other one comes all the way up to the leakage switch test. So anyway, so here we are. I followed those two wires up, one to the wafer switch, and one actually goes to this control in the middle. Main control. There it is. That's the connector. Okay, so we've got 224 ohms on that one. So this is the 55 volt green to green yellow is 224 ohms. Final one to do is our 12 volt yellow winding, which is the heater winding. So yellow and yellow was well, they're going to be on the underside, aren't they? It's on the front, these two here that come through. Here they are. So I've got one connecting to pin 7, sorry, pin 7, and the other connects to pin 2. So pin 7, and the other one it's still connected on top to pin 2. So there's it connected there, and 12 volt winding, yellow to yellow equals 14 ohms. Right, so we've now measured all of the windings on the power transformer, and it's all showing as they've all got DC resistance, so they are all working as such. So now what I can do I can now connect the unit to a power supply, and I shall measure the input voltage, and then I can take measurements for those windings as well. Right, let me connect that up. Okay, so welcome back. So what I've done is, as this has, I don't think it's the export mains transformer, and looking at the windings, I don't think it is. I think it's just got 110 volt winding, primary. I've connected the power cable to a step down transformer that puts out 110 volts AC, 100 volt amps, with a 230 volt input. I've connected that, sorry for the mess, to my light bulb limiter. It's got a 100 watt bulb in. I might, no, it'll be okay. So what I'm going, and then I've connected up my voltmeter to the two black and black leads, so I can measure the input voltage coming through the light bulb to the unit. We should get 110 volts. So what I need to do is I need to switch the unit from check, I think, shorting first. I think that's a good place to start. Turn it on, we'll put it to the up position to you can put it in any position. What I'm going to do is, when I hit this switch, we'll start getting voltage through. If the bulb glows extremely bright and stays on, there's a short somewhere. If it comes on then dims down, we're okay. So 3, 2, 1. Nothing. I can hear something happening, but I'm not getting any volts. I'm not getting any voltage. When I touch the bulb, I can feel it's getting warm, so I know there's current being pulled through. I know I've made an error on the connection. Hold on. Let's turn off the bulb. What I've done is I haven't made the right connections down here. I've got to actually connect between the, essentially the two input wires. Let me just do that. Right, so now I'm connecting between the two, the live and the neutral. Gonna hit the bulb. There we go. So we're getting, let's put it on a better range. We've got 113.5 volts going in. The bulb isn't lighting up, so there's no short. So in theory, we all seem to be okay. Right, carry on. So I've now made the connections to the red and red yellow, the 500 volt winding, like we did earlier. We're still measuring AC, 600 volt range. Just let that sort itself out. So this is our red to red yellow, and we're looking for 500 volts. I do actually expect a tiny bit more, but we'll see. 3, 2, 1. So the high voltage winding is putting out unloaded. I think is a fair way to put it. 540. Just let it settle down. .546 volts AC. It is moving around a little bit. Yeah, okay. So we know that the high voltage winding, one, it is it's not open, so it's closed, and two, it's putting out some nice voltage. Okay. The next step then will be the 55 volt green to green yellow. I'll make those connections. Okay, so the green to green yellow connections made as they were before when checking the their DC resistance. We're in the 200 volt range because we're expecting 55 volts AC, a bit more when it's unloaded. Off we go. Brilliant, look at that, 60.7 volts. Perfect. Okay. Happy with that. And the final one is the 12 volt winding yellow to yellow. Yellow to yellow. So yellow to yellow connections made just as they were before. Switch the meter to the 20 volt range because I'm expecting 12 volts. On it goes. You get, as I said before, they're all going to be higher than expected because the tester is unloaded, i.e. there's no valves in it, there's no current flowing. 13.2 volts AC. Perfect. Right, so all of those tests have now confirmed that our mains transformer is working as expected. There's no short, everything, all the voltages are there. So I can now move on and start to replace our capacitors. Right, thanks for watching.